Hello viewers, in today's session we are going to discuss another important problem from derivatives of inverse function, and we have already discussed how to derive the formula for the derivative of inverse function in our earlier video, right? And here we are going to find out the derivative of the inverse of this function f of x. At this point, x is equal to natural log of 7 over 3. So here we are given the function f of x, that is the natural log of x square plus 1 divided by x square minus 1 for all x greater than 1, right? So let us start, and let us first find out the inverse of this function f of x. So now let us take the function y is equal to f of x, and here we are given f of x as log of x square plus 1 divided by x square minus 1. So now this expression can be written as e raised to y is equal to x square plus 1 over x square minus 1. Because see, if we have say y is equal to a natural log of a, then by definition of logarithms, we can write this expression as a is equal to e raised to y, and our a is x square plus 1 over x square minus 1, right? So now let us find out the value of x using this equation. So we have e raised to y, here we have x square minus 1, here we have x square plus 1. So we can now write x square e raised to y minus e raised to y and x square plus 1. Now taking x square to the left hand side, we can now write x square e raised to y minus x square, and here we have 1 plus e raised to y. So taking this negative e raised to y to the right hand side. Now taking x square common, we have e raised to y minus 1, and here we have e raised to y plus 1. So we have x square e raised to y plus 1 over e raised to y minus 1. So now we can write x is equal to square root of e raised to y plus 1 over e raised to y minus 1. So now from this equation, we can write x is equal to f inverse of y, right? Now see, this x belongs to the domain, and this y belongs to the range. So we can write x is equal to f inverse of y. So here if we take f inverse of y, we have f inverse of y is equal to square root of e raised to y plus 1 divided by e raised to y minus 1. So this is the expression for the inverse of this function f of x, right? So now this expression can also be written as f inverse of x. Now changing the variable or the notation, that is x for y, we can simply write f inverse of x is equal to square root of e raised to x plus 1 over e raised to x minus 1, right? So now let us call the inverse of f, that is f inverse of x is equal to the function say g of x, right? So for simplicity or for the simple notation, we can now write g of x as f inverse of x, right? Okay, so now here we are given x is equal to natural log of 7 over 3. So the second step is to get the value of f inverse of x or g of x at this point. So we can now write f inverse of natural log of 7 over 3 as g of natural log of 7 over 3, and we can now replace this x by natural log of 7 over 3. So we have e raised to a log of 7 over 3. Then here we have plus 1, and here we have e raised to natural log of 7 over 3, and here we have minus 1. So now here we can use this result, that is e raised to natural log of p is equal to p, right? So we can now write square root, and e raised to natural log of 7 over 3 is simply 7 over 3 by using this expression. And here we have plus 1, and here we have 7 over 3, and here we have minus 1. So now we can write g of natural log of 7 over 3 is equal to square root of 7 plus 3 and divided by 7 minus 3, and this 3 and this 3 get cancelled, so we are left with 10 over 4. So this is square root of 10 divided by 2, right? So now we have obtained the value of the inverse function at this point, that is natural log of 7 over 3. So now the third step is to get the derivative of this function f of x. So we can now find f prime of x, which is d by dx of y, and y is our function, that is the natural log of x square plus 1 over x square minus 1. So here we have to find out the derivative of this log function, and the derivative of log of x is given by 1 over x, and for x we have this entire term. So we can now write 1 over x square plus 1 over x square minus 1, and then by chain rule we have to find the derivative of this rational function, that is x square plus 1 over x square minus 1, right? So now we can write x square minus 1, taking x square minus 1 to the numerator, and here we have x square plus 1, and to get the derivative of this function we have to make use of this uh, quotient rule, that is d by dx of u over v, and we have v du over dx minus u dv over dx divided by v square. So u is x square plus 1 and v is x square minus 1. So here we can now write x square minus 1, then derivative of x square plus 1, then we have minus x square plus 1, derivative of x square minus 1, and in the denominator we have x square plus 1 square. So now we have this term, that is here we have x square minus 1, right? Okay, so now this term get cancelled with this one, so we are now left with 1 over x square plus 1. We have x square minus 1, derivative of x square plus 1 is simply 2x, and then here we have x square plus 1, and derivative of x square minus 1 is 2x, and in the denominator we have x square minus 1. So now simplifying this term, we have 1 over x square plus 1 multiplied with x square minus 1, and in the numerator we can now write 2x cube minus 2x, and then we have minus 2x cube and minus 2x. So this term and this term get cancelled. We are left with minus 4x over x square plus 1 multiplied with x square minus 1 can be written as x raised to 4 minus 1, because here we have used this identity, that is a plus b and a minus b, right? So the derivative of this function is given by f prime of x, that is equal to minus 4x divided by x raised to 4 minus 1. So now the formula for the derivative of inverse of f of x is given by d by dx of f inverse of x, which is equal to d by dx of g of x, because we have assumed that f inverse is equal to the function g. So this is g prime of x, and this that is the derivative g prime of x is equal to 1 over f prime of g of x, right? So this is the formula for the derivative of inverse of the function f of x. So now we have to find out the derivative of the inverse function at this point. So let us replace these 2x by natural log of 7 over 3. So we have now d by dx of f inverse of x at this point, that is x is equal to natural log of 7 over 3, and this is equal to g prime of natural log of 7 over 3, and this is further equal to 1 over f prime of g of natural log of 7 over 3, right? And we have already calculated the value of g of natural log of 7 over 3, and that is equal to square root of 10 over 2. So we can now write 1 over f prime, and here we have square root of 10 over 2. So now to get the value of f prime of square root of 10 over 2, we'll make use of this expression, right? And we'll replace this x by square root of 10 over 2, and here we have minus, we can write 1 over minus 4 times square root of 10 over 2 divided by square root of 10 over 2 raised to 4 minus 1. So now we can simplify it. So we have 1 over minus 2 times square root of 10. Here we can cancel this 4 with this 2, and in the denominator we have 100 over 16 minus 1. So this is 1 over minus 2 times square root of 10 divided by 84 over 16. So now we can write this expression as 1 over minus 2 times square root of 10 multiplied with 84 over 16. Now this is 2 times 42, and this is 2 times 8, this is 2 times 21. So we have minus 21 over 8 times square root of 10. So viewers, the value of the derivative of the inverse function, that is f inverse of x, at this point x is equal to natural log of 7 over 3, is given by this number, that is minus 21 over 8 times square root of 10.